Hello guys, hello everybody, hello Philippines, hello world, hello other parts of the world. Oh my God, so I'll be giving a specific problem on thermochemistry that talks with enthalpy change of the reaction, enthalpy change of combustion, okay, in relation to enthalpy change of the formation of the reactant, enthalpy change of the formation of the product also. Okay, and it's related also to Hess law. So we will review what is Hess law. Anybody can really differentiate or can really define what is Hess law. This is very useful in physical chemistry, especially in dealing of thermochemistry topic. Okay, in relation to thermodynamics, right? Heat energy transferred from one system to another system, or from system to the surrounding, from one point to another point, from higher temperature to lower temperature. So heat is really transferred every time. Okay, go back to this thermochemistry. Okay, Hess law, what's that? The total change of enthalpy, okay, during the entire course of a chemical reaction that is independent to the number of steps taken. Okay, for example, if there's a lot or series of chemical reaction from 1 to 10, so that 1, 2, 3, 4 will not matter at all. The important is the final stage and the initial stage will matter. Okay, like that. So it can be stated differently also as the change or the sum of the changes of the enthalpy of each reaction step is also equal to the change in the enthalpy of the overall reaction, something like that. Okay, so we need to cancel that out somewhere along the way, and what's being left is your final chemical reaction. Okay, that's Hess law all about. So your identification really is enthalpy change, or heat change. Okay, sometimes using the standard heat of combustion and the standard enthalpy change of combustion. Okay, sometimes also the words are doesn't really matter at all, because sometimes also enthalpy change of combustion don't put a change, only like this, enthalpy of combustion, okay, and then heat of combustion. But sometimes other textbooks and other reference sources, it will state that change. Okay, enthalpy change of combustion, enthalpy change of the reaction, okay, heat change of combustion, but it's just totally the same by not putting the word change. It's just okay. Why they emphasize the word change? Because there's always a final state and the initial state. Because enthalpy is a state function. State depends with the final state and the initial state. Final stage and initial stage. So that is enthalpy change of reaction all about. So state function talaga siya. Okay? So that's the main focus of Hess law. So going back, I'll give you the problem now. Okay? Number three. Three, right? Yesterday you have two, right? So the continuation. Calculate the energy released when 88 grams of acetylene gas with excess oxygen according to the equation. 4 moles of carbon dioxide plus 2 moles of water is equal to 2 moles of acetylene gas plus 5 moles of oxygen gas. The enthalpy change of the reaction is equal to 2,559 kilojoules. And we have also some additional data for the enthalpy change of the formation of carbon dioxide gas. 4 moles of carbon dioxide gas is equal to 2,559 kilojoules. 2 moles of water liquid is equal to 2,559 kilojoules. We have, ethylene gas, acetylene gas. We have 2,559 kilojoules, 2 moles. And also, oxygen gas is equal to 2,550 kilojoules and 5 moles. In your class, this is only for the purpose of discussion, because actually in the natural process, we don't have value of enthalpy formation of oxygen gas. Okay, the purpose only is to have the discussion, the solution, but it's not really existing because moles of oxygen don't have an enthalpy change of formation, because it states in the theory and concept of thermochemistry that a gas element or monoatomic gas or single, could it be free element, automatically the enthalpy change of formation is equal to 0 at standard temperature at 288 Kelvin. Okay, so automatically. So for example, if the examination will give you a chemical reaction, okay, like that, so it's automatic that that is 298 Kelvin if they present the data of the delta head of information. Okay, the delta head formation, something like that. Now, if they ask you to obtain the free Gibbs energy change, then you can use the 298 because in the, in the Gibbs free energy reaction formula, there's a temperature there, and you will be shocked. Where can I get the temperature? Even though the problem is not giving the temperature, that's automatic 298 Kelvin, so that you can substitute that there in case the question will ask for the change of free energy. That's automatic. Please, put that in your brain cells already. Okay, something like that. Okay, because this enthalpy change information is really at standard temperature. Okay, so we are considering here the room temperature, which is 25 degrees Celsius, since it should be converted to Kelvin. So Celsius plus 273 equal to 298 Kelvin. That's standard temperature. Okay, something like that. Okay, now going back to the chemical reaction. So can you read this for a moment? Okay, so that you can also take your blank sheet of paper and try to solve this. Actually, this is not very difficult. Okay, this is just, very basic to consider. Okay, I am implying only the theory and concept so that you can understand and you can apply that in a more complicated one. Okay, so let's start with the basic foundation, right? Okay, now, okay. So, what is the energy released? So actually, sometimes me also are confused because it's not specified what kind of energy is being released. It's not mentioned here, right? There's a lot of energy that surrounds us, right? Chemical energy, mechanical energy, light energy, acoustic energy, radiation energy, thermal energy, pneumatic energy, hydraulic energy, mechanical energy, electrical energy. Okay, and there's a lot of energy, geothermal energy, okay? Underground, something like that. There's a lot of energy, kinetic energy, potential energy, blah, 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 so on. So internal energy, something like that, okay? So, identify this. So the only way to identify that one is the given of enthalpy change of the reaction, that's H, so automatically that's heat. Because enthalpy change, H, is directly proportional to the heat Q. Okay, like that. So it's just totally similar in effect. So we can say pala that the problem requires heat energy release, even though not specifying the heat word here. Okay, like that. Because the question is only calculate the energy release, not the heat energy man. So you will be the one to think that it is really heat energy through the process because delta H reaction is given already. So the problem is if we don't give the delta H reaction, so that will be more confusing. Okay, so thanks God, there's a delta H here because it's an enthalpy. So automatic, what is being required is the heat energy released. Okay, specifically. Now, it says in the problem that 88 grams of acetylene gas with excess oxygen according to the equation. Okay, now take note of the chemical reaction, guys. Okay, it's not reflecting to the problem. Okay, so what you will do now for this? The chemical reaction given in the question is endothermic reaction. But the problem asks for exothermic reaction. See, heat energy release, that is exothermic. Okay, or spontaneous process or spontaneous chemical reaction. So, all you have to do is to reverse the chemical reaction so that it will become an exothermic. See how full the questionnaire is. Okay, so if the students will not detect that right away, so the entire process of resolution will be wrong if you still use this one equation, because this chemical reaction represents endothermic reaction and non-spontaneous reaction. You cannot use this chemical reaction. You will reverse the chemical reaction so that you can achieve an exothermic reaction and a spontaneous reaction. Now, if it is an exothermic reaction, then you have to change your enthalpy of reaction into a negative sign. See? So, it will become negative 2559. Oh my gosh, so it will become entirely wrong, huh? Really, 100% wrong if you will not reverse the chemical reaction, okay? And the other given also here, and the other side, support data, okay? I mentioned a while ago. Okay, let's check it out if it will be applied during the solution process. Okay, when we solve this problem. Okay, like that. So we will start now to the stoichiometric relationship of 88 grams of acetylene gas. Oh my gosh. Acetylene gas, guys, remember that is hydrocarbon, the study of carbon atoms and hydrogen atoms. Okay, like that. Again, you should also remember the formula of hydrocarbon, okay, the determination of carbon atoms and the hydrogen atoms in organic chemistry. This is very useful in petroleum chemistry. Petroleum means specific, the raw materials are really crude oil, okay, to produce fuels, diesel fuel, kerosene, gasoline, naphtha, okay, something like the asphalt, and anything, chuba chuchu, okay, like that. Any petrochemical product starts from the raw material of petroleum or crude oil, okay, something like that. We have polycarbonate, olefin, high density polyethylene, polyvinyl chloride, the PVC pipe, okay, the low density ethylene, LDPE. So those are the petrochemical products from the raw material called petroleum, specifically crude oil. Okay, now going back to this equation. Because the chemical reaction is really a raw material, petroleum talaga siya because of acetylene. Okay? Like that. Okay, let's reverse na. Go. Okay, go. I-reverse na nato siya guys ha. Okay. Take note. You should be concerned with the phases and the states of matter. What do I mean with that? In this thermochemistry. And then we need to familiarize also guys the different process. We should only take into account four processes. It's very useful in thermochemistry. The first is evaporation or the vaporization. Second will be the reverse, which is the condensation. Number three, we have the sublimation. Okay, and then number four, we have also the reverse of sublimation is deposition. Okay, deposition is not really discussed very well in college, but I research very much for this. This is the reverse of the sublimation. Deposition or de-sublimation. And the other one also is, from gas, okay, from solid to liquid. What is that? A change from solid to liquid is known as fusion or the melting point. Okay, the reverse for the melting process or the fusion from liquid to solid, that is solidification. Okay, solidification, not crystallization, imagine solidification. Okay, like that. That's the point. So that for 5 processes or 6 processes, you should be familiar with that because it will be involved in thermochemistry problem solving. Okay, something like that. Especially the water pure substance. Don't forget that one. Okay, then you will memorize also the values. For example, latent heat of vaporization. Ganon. Okay, what is the latent heat of vaporization? Vaporization of water at 100 degrees Celsius. Ganon. What is the molar heat of vaporization of water? O ganon. What is the latent heat of condensation of water? Okay, memorize. What is the specific heat capacity of water? Oh, something like that. But take note also, in latent heat of fusion, your temperature there is 0 degrees Celsius and at 100 degrees Celsius because that's fusion. Okay, like that. Okay, you understand the point? Okay, that's it. I don't have to mention the figure researched by the it will take time also. That's not my concern really. It's only connected with this problem solving. Okay, like that. For example, 79.7 calorie per gram. What is that? Tank. A, blah blah blah. Heat of sublimation. B, latent heat of fusion. C, latent heat of condensation. The answer will be latent heat of fusion is 79.7 calorie per gram. Latent heat of fusion of water. Ganon. Okay? So that's it. So memorize all the constants of water para wala na siya lusot. Okay? Okay? About water, the density, at 4 degrees Celsius, memorize everything about that, especially the pressures, Okay, going back to the solution. Because I advise you, because if you will memorize that one, it will retain in your brain cells. even though you will reach 40 years old, 42 years old, 43 years old. Because I memorized that when I was in high school in chemistry. Right? I told you when I won the chemistry quiz bowl in our school, that's the time, I really studied hard for chemistry, and it's really the drive force for me to take up chemical engineering. Okay? Even though I'm not good in mathematics. I'll tell you honestly, I'm not good in mathematical ability. Okay, but I am really enjoying pure sciences. That's my drive. Okay, even though they tell me before you will not become an engineer if you're not good in mathematics, but I really tried to exert effort to defeat what they said, and it's really true. It's not really a requirement to be good in mathematics to become an engineer. Okay, the requirement is you have really to be good in science and you have to study very well. Okay, that's it. And it's not true that mathematics engineers are on mathematics. No, it's not on, because mathematics is only incorporated in science. Okay, number one, science, because mathematics is only within pure sciences to solve what is being required. Okay, like that. Okay, meaning to say the original is a science. Mathematics is only within science to solve what is being required in different science problems. Okay? Like that, like Pythagoras theorem. Okay? Pythagoras is a scientist. Okay? And he discovered the law of right triangle. Right? If you can remember that one in algebra. So just like or trigonometry. Okay, going back here. Okay, now 88 grams. Work calculation siya sa, di ba? Hoy, chemical engineers, are you listening right now? Or to those 50-year chemical engineering students that will be able to take the chemical engineering board examination this October 2021, you can watch also this live stream. Okay? I think it could also help a little bit. Okay? Like this. I'm not telling you that it's gonna be like this, but I am also picking up some previous chemical engineers examination question also. I don't have to mention that it's gonna be 1998, 2000, but some of the problems I presented here is past or previous chemical engineers board examination question. Okay, I don't have to tell every time, right? Okay, so like this. Okay, acetylene gas. Come on, guys. 88 grams of acetylene gas. Okay? Walang katapusang pagkukompute ng mga molecular weight, atomic weight, like that. Okay? So, it's gonna be like that. So, molecular weight, you have to identify or to determine that one because you have the mass. It is related to each other. Okay, when you multiply that with the molecular weight and reverse that molecular weight, then you can cancel that out. What's been left in your equation is the number of moles, and then you have the number of moles in your chemical reaction here, the stoichiometric relationship. Then bingo, you can solve what is being required, and then you can put the energy that is given here, which is the enthalpy of reaction, which is negative 2559 kilojoules. Then bingo, you can solve what is being required, something like that. Okay. Okay, so molecular weight. Okay, carbon 12 times 2. Oh, where's my calculator? Oh my gosh. Calculator, please. Charot. Okay, carbon 12 times 2. 24 siya. Hydrogen 2 times 1.016. Okay, pila na siya. Okay, so I advise you to memorize the most common atomic weight, ha? For example, the most common atomic weight of oxygen, fluorine, chlorine, sulfur, magnesium, calcium, sodium. Memorize everything about that because that is very common. Do not depend really on handbook. Don't depend on the book. Memorize. Okay, so that you can, when you take the examination, tuloy-tuloy siya ba? Spontaneous answering the questions without any interruption. Di ba ang saya-saya? Okay, ganun siya. Okay, so 1.016. Okay, 1016 times, ano ba yun? Charot. Times 2 is equals to 2.032 plus 24. So I have a 26.032 grams per mole of molecular weight of acetylene gas. Actually, this acetylene gas is used in welding operations, okay, like that, because this acetylene is very flammable, something like that. It will undergo a rapid oxidation to produce flame, open flame, a smoke, and a very bright light. Okay, something like that. So 26.032, okay, grams, then mole of C2H2. Okay? Ganun siya. Okay. So 1 mole siya sa numerator because it's still the molecular weight. And now after this one, we need to incorporate now the stoichiometric relationship na in the reaction. So how many moles of acetylene in the reaction? Oo, di-reverse naman din nato, di ba? So it's 2 moles, right? So put 2 moles, okay? At the denominator, 2 moles of acetylene gas. Now, in this reaction data, guys, it's given here that the enthalpy change of formation of acetylene gas is equals to positive 2559. Since we reverse now the chemical reaction, it will become negative. And then it states that 2 moles of C2H2, there in 2 moles of C2H2 acetylene, there is negative 2551 kilojoules. So we will apply that here in our equation here. So in every 2 moles of acetylene gas, so your numerator will be negative 2559 kilojoules. Okay? So in every 2 moles of acetylene, there will be a negative 2559 enthalpy change of formation man siya. Okay? So, cancel, 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 cancel. What's left is now the kilojoules. So it's very clear that this is a unit of energy. So this is heat energy. Okay, so do the math. Okay, 2 times 26.032 is equal to 52.64, 064, ganon. Okay, and then 88 times 2559 is equal to 225,192. Okay. As you notice, guys, the way I spoke and the way I pronunciated the words is very clear and something, there's an enunciation like that. Because before also when I took up Bachelor of Science in Chemical Engineering, my first choice of course is really to become a broadcast journalist. Not really an engineer, okay? Because I love very much English subject and also science subject. So I weighed the two. So when I graduated in this is only a little bit of information. When I graduated in high school, so the scholarship offered to me is academic. It's not really that on the CAS or College Arts and Sciences. Okay, now when I look, there's no journalism there because I want really to become a broadcast journalist when I was young, something like that. Because I'm joining too much in journalism. I joined editorial competition, essay writing competition, like that, okay, feature writing competition, news writing competition. I joined a lot about that because I really love English. In fact, I joined declamation contest, oratorical contest when I was young. In my high school or whatever, chupa chuchu. Okay, like that. There's no such scholarship about that. So my second choice really, since I love science, the most closer to that is the Bachelor of Science in Chemistry. Okay, like that. But there's no BS Chemistry at the time in the Cebu Institute of Technology, the former CIT University now. So what's really most close to that is the Bachelor of Science in Chemical Engineering. Okay, because I told you before, right? I'm not good in mathematics. That's why I opted to BS chemistry first. Okay, then I said to myself, if I can make it, why I can't? Something like that. So I really pushed through because we belong to a poor family. We don't have that much money for my parents to educate me, and I'm relying only for the scholarship. Actually, that is a government scholarship, presidential scholarship funded by, that was the time of President Fidel V. Ramos, something, the president at that time. Okay, so I enjoyed a lot of the academic scholarship, and then I proceed to Bachelor of Science in Chemical Engineering, having the thought that I will never be afraid of what they say, that if you are not good in mathematics, you will never become an engineer. I'll try to break that out. That's why I do a lot of effort. Let's see what's happened to this. Okay, when I start with the first year, chemical engineering, second, and I found out it's not really that too much. I can make it also. I found out, I remember I became a dance lister when I was in first year college up to third year college. But when I go to fourth year and fifth year in my chemical engineering, I could not manage already to to become a dance lister because it's so hard now for me, especially there's a lot of mathematics now that is advanced engineering mathematics, differential equations, such like that, and I cannot manage anymore to have a higher grade. And admittedly, I did not become a dance lister on that years. But I have an average grade also because I have to maintain grades or else I will be eliminated in my academic scholarship if that is the case. What I mean is I cannot maintain a higher something chupa chuchu in my grades for that particular mathematics or major, the unit operations and the, what do you call that one? Industrial chemical process and control. I found it difficult to really. Okay, and then subjects about all about memorization. I love it too much. That's my strength and my forte. But the problem solving, I found it very weak. So I said to myself, "Oh Lord, guide me. I have to develop in theory and concepts." Anyway, the problem solving can be understood very well if you know the basic concepts and theories and principles. So what I did, I go to the library every time my vacant. I will never do chismis. I will never do chika chika. I don't even go to Colon, Cebu City just to have window shopping or to go to the Bragada and drinking alcoholic beverage. I never do that. Okay, I'll always stay food in our school in the CIT like that. And every time there's a time also I sleep in the library. It's just because I'm studying different kinds of books. And then in the afternoon I have to bring 3 books, 4 books, 5 books in my home. Okay, in my home in the Tinaan City of Naga Cebu. Then I go to the CIT University and there's Natalio Bacal to Cebu City. I always bring books, 3 books, 4 books, 5 books, 6 books. No, because I'm never satisfied because some instructors really are very fast in their discussion, especially the top-notchers instructors in our school. Because our school is noted to be a home of top-notchers really for engineers. Okay, our school, Cebu Institute of Technology, they are very, very brilliant, instructors. But the problem is they really discuss in a very spontaneous manner, very fast. Then me, I cannot really understand that one because I told you a while ago I'm not good at mathematics, right? So how can I manage this one? So really, I put a lot of effort to go in the library, and after the library, I still study in my home. Okay. And after that also, I also study in the transportation vehicle. I read in the books while the vehicle is moving, going to the school. My life is gonna be the routine. So I did not. Maybe I will just rest if there are important occasions, something like that. But most of the times, I really study in every angle. Angle of inclination. Oh my God, really? Because I want also to really pass that one because they said blah 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 so on. So okay, then I have also to prove because we belong also to a family that is really what do you call this one? Academically achiever, something like that. Okay, so not really to prove, but I would like to, I would like to really tell them that we know that much academically also, something like that. And then I studied a lot. Okay, so I remember also in the last day of the board examination, I slept only I think 3 hours. Okay, I studied the whole night. Then I wake up, I think 3 o'clock. I sleep almost 3 o'clock, something like that. And then the examination will start 7 o'clock in the morning. Imagine how many hours of sleeping only. Okay, I think 3 hours or like that. Okay, because at that time really when I took the board exam, I really want to become the top notcher. Okay, I was very arrogant in my motivation. I have to be honest with you guys, so, because I want really to become one of the top notchers, so that I would really pass something, and it came true. Okay, because if I don't have a very high aim, maybe I will just flunk or fail because my aim is only passing. My really aim is to become a top notcher at that time. Okay, to be honest with you. Okay, not to be hypocrite. Okay, I really want to become a top notcher at that time. Also, okay, that's why I studied a lot. Okay, So the only poor area is that I'm not really that good in mathematics. Okay, maybe if I am good in mathematics, we don't know, right? Because I already have the theories, the concept, the memorization, something like that, and that's my forte really, memorization. Okay, some theories and concepts and principles. Okay, and it's easy to adapt also a little bit of problem solving if you have the foundation of theories and principles. You can really understand naman talaga siya eh. Unless the problems are too difficult to consider already. And you know what is chemical engineering is very difficult in problem solving, especially the unit operations. Okay, especially the leaching, the distillation, something like that, drying, filtration, flotation. Oh my gosh, oh, very difficult. Humidification, charot, screening, filtration. Oh my gosh, how can I do this? Okay, I'll never fail, but I'll just get the average grades for that. Not really that hard. Okay, that's it. Oh, going back to solve the problem, too much chica joule. Okay, that's it. Okay, 225192 divided by 52.06, or is equal to 4,325.29 kilojoules. Okay, that's going to be our answers in the enthalpy of change of acetylene gas. Oh my gosh, 4,000 shot. 4,325.2 kilojoules. Okay, guys. Okay. Some also question put moles in the denominator. Okay, be careful also to that. If that is the case, then you have to multiply Sha with number of moles pa in order you can attain the kilojoules. Okay? Something like that. Or there's a conversion factor from kilojoules to calorie to British thermal unit, BTU, and BTU to erg. Erg is a unit of energy. Remember that one in English unit. Okay, in employing the centimeter and the grams, just like Newton. Okay, kilogram meter per second squared. So that is gram meter per centimeter squared. Okay, dyne. Dyne is the unit of force, like that, and Earth is the unit of energy. Okay, Newton is the unit of force, then Joule is the unit of energy. Joule is equal to Newton meter because that is derived from force times distance. Okay, it's very clear. Usually, what will come out in examination is the dyne thing. The question will say like this: what is the unit of an energy? Okay, if we employ centimeter and grams, A, ganon, B, ganon, and there's choices are dyne. Your answer will be dyne. dy and E. Okay, and sometimes also simple. I'm relating to had the actual examination before, as far as I could remember, and then there's also something. How many long ton? Ganon. But we understand in college, or in my high school days, that a ton is just only a ton. Right? 1 ton is equal to 2,000 pounds, as we can remember. But it's not. There's a one long ton, and there's also a one short ton. Okay? The one short metric ton is the one that is 2,000 pounds. But the one long metric ton is the 2,200 pounds. Okay, so there's two units of ton, the long metric ton and the one short metric ton. Now, in the problem, it is not specified. That's automatically the short ton. That's why we are using them every time, 2,000 pounds. But if it will mention in the problem, you say, a one long ton of blah, 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 the problem, then use 2,200 pounds. Sure, you will be wrong if you still use the short metric ton. Okay? Conversion factors in English unit. Okay, something like that. You memorize the conversion factors very well, huh? Especially the gallon to liters. Okay, 1 gallon is equal to 3.785 liters. Mga ganun siya, chuba-chucho. Okay? Okay, take note for that also. Okay? And then, 3.28 feet is equals to 1 meter. Like that. 3048 meters is equals to 1 feet. Okay, 100 centimeters equals to 1 meter. Okay, 2.54 centimeters equals to 1 inch. Ganon. Inject that in your brain cells so that when you are still young now, you are in your high school or high school, if you memorize that and retain in your brain cells, if you reach 30 years old, 40 years old, you are now working in the real world, you can still memorize the conversion factors. Something like that. Okay? So that's very helpful really to pass certain examinations. It doesn't need to be intelligent in passing the examination, I tell you frankly. Okay? So just average and a little bit above average, something like that. It can be okay in passing certain examinations, not only board examination, anything kinds of examination, okay? Like that, okay. Finish collapse for this. Calculate the energy released, blah blah blah. So this is one of the examples of thermochemistry problem solving. Thank you guys for listening, and then I hope you like the video. Sorry for relating to you my past experience. Okay, so that's only sharing of information to everybody, guys. To those who do not know me personally, also. Okay, and thank you so much if you subscribe my YT channel also. Okay, and then you can click for some newest updates of I Am a Singer Eternal Voice that focuses on the occupational safety and health, okay, and pure sciences, specifically, okay, chemical engineering sciences, or chemistry, whatever, chupa chupa chupa. Okay, personal vlogs, and a little bit of singing moments, biritan for portion. I love really to build out high notes. Okay? High note talaga. Okay. Like that. Thank you so much. Bye bye everybody. God bless. See you later. Oh my gosh.